section of this lesson and this course introduces you to some of the concepts of data warehouses and why they are so important. Let us discuss data warehouse in the next screen. A data warehouse is a data structure that is optimized for use in business intelligence activities. These activities use the data stored in the data warehouse to create reports, perform analysis, and predict trends. A data warehouse is actually stored in standard databases using standard concepts. We'll look at the structure and storage of data in the next few screens in detail. However, suffice it to note that data warehouses are simply optimized architectures of data meant for business intelligence. Business intelligence processes extract useful information from data warehouse. When an organization needs to use business intelligence to analyze information, it is important to realize that data for this can be stored in a multitude of places. For instance, organizations store data in databases, customer relationship management, CRM systems, enterprise resource planning, ERP systems, Excel spreadsheets, web services, and external entities as well. The conceptual diagram on the screen signifies this concept. A data warehouse brings all of these disparate pieces of data together into one clean and verified data. Data is also standardized within the data warehouse so that there is no ambiguity in results returned. For instance, currency, weights, distances, and dimensions are all standardized into a single unit for each, such as US dollars, kilograms, or meters, as required to ensure the same value is not misinterpreted in the wrong unit. One very important thing that data warehouse enables is storage and analysis of older data. This historical data allows one to analyze how a value has changed over time. For instance, you might want to check how the price of a particular product has changed over the years. The prime importance of data warehouse structures is that it provides a great stepping stone to even more powerful structures in business intelligence. This is not to say that the structures in data warehouses are not quite powerful themselves. These structures are highly optimized for returning results in ad hoc queries that can be executed against it. However, data warehouse structures are not optimized for transactions. That is, where data is entered, updated, or deleted on an ongoing basis. Data warehouse works on a concept called a data mart. These are singular units of related data that can be analyzed within the data warehouse. You will learn about these very soon in this lesson. Let us discuss the differences between database and data warehouse in the next screen. The primary difference between a database and a data warehouse is the reason why they are used in an organization. A database is used to store raw data, that is, transactions and data that support those transactions. For instance, in a sales database, the data that stored details of products, customers, and employees support the actual data that records each sale that happens. Similarly, in a CRM database, all customer and employee data is used as support for the leads, calls, and other transactional data. This is why normal databases are meant for OLTP, which stands for Online Transaction Processing. On the other hand, data warehouses are used as a stepping stone towards OLAP data structures. OLAP stands for Online Analytical Processing and is a very important concept of business intelligence. Data warehouse structures, while implemented within a database, have a structure that allows moving from a raw database structure to the OLAP. Database structures and tables are stored in a normalized fashion. You learnt about normalization in a different course, 70-461, which introduced this concept. This process reduces redundancy of data by splitting them up into smaller chunks and storing in different tables. This is highly practical when entering a lot of data quickly. This structure is extremely slow in querying due to the number of joins between all of these smaller table chunks. Data warehouse structures, instead, reduce the number of tables required for a query by denormalizing the data. While this increases redundancy, this trade-off is quite acceptable given the amount of speed you gain on querying the data. Another big difference is that data within transactional databases is usually not validated or standardized. That is, while front-end applications for data entry would perform syntax and data type checks, the database itself would not verify that the contents of the data are valid. Also, the same database used in different scenarios or locations can have a number of different units of measurements. For instance, depending upon the country, units of currency, weights, and lengths could all use different units. Collating all this with only a value means that querying it can give you incorrect results. You need to consider getting results collated from lengths in meters and feet by considering them the same. In the case of data warehouses, processes ensure that the units are validated and standardized. OLTP databases are also incapable of storing historical data. While possible, it is extremely complex to figure out how some value has changed over time. In the data warehouse structures, this is an intrinsic part as long as it is enabled. Finally, another major difference is in how indexes are used. In OLTP databases, a minimal indexing strategy is recommended so that writes to the database are not bottlenecked due to the frequent index rebuilds. On the other hand, data warehouses are meant for querying and therefore should have indexing for all appropriate columns. Let us discuss the uses of data warehouses in the next screen. This screen explains the major uses of data warehouses. The primary reason for using data warehouses is that OLTP databases are not good for queries. Due to the high degree of normalization used in transactional databases, querying them becomes a performance bottleneck. Any major query requires retrieving data from multiple tables using different types of join conditions. When trying to produce reports, this becomes an issue since reports are specifically meant for querying and not for updating the database. A data warehouse structure, which we will discuss in the next section, is a logical structure that is well considered for moving raw, transactional data into one that is extremely optimized for querying. When performing business intelligence operations, which consist of analyzing thousands, if not millions of records of data quickly, a standard structure as stored in a table is inefficient. In fact, even a data warehouse structure is not optimum for that level of analysis. OLAP structures, therefore, have a completely different structure and implementation. Databases, however, cannot be directly converted to an OLAP structure. Data warehouses are the intermediary structure which allows OLAP tools to convert the data to the OLAP structure. One of the things that happens in many organizations who do not invest in data warehouse implementation is that they fire all queries directly on the transactional database system. For instance, when managers want to see sales for products, say for the last month, they run reports that query the same database where transactions are going on at the same time. This can cause issues like locking and slower writes. Also, reports themselves can be quite slow since the transactional database might not have adequate indexes defined. Instead, If a data warehouse is created, any reports and queries can be run off of that while the transactional system just receives the inputs. Finally, a data warehouse is a great way to build an information repository within the organization, one that stores data and allows you to query from any part of it and gives you results instantly. This growth of information enables creating a knowledge base and get more accurate results when using analysis tools over time. In the next screen, we will discuss how to implement data warehouses in SQL Server 2012. SQL Server 2012 is highly optimized to provide data warehousing services. As mentioned earlier, a data warehouse is implemented via a normal database in SQL Server, including the data warehouse structures maintained as standard tables. Relationships between tables are optimized by the system automatically. In fact, SQL Server 2012 contains certain components that recognize when tables are stored in a data warehouse structure as opposed to a standard database structure. These components then perform additional optimizations to further increase performance.